We're live. Hi everyone. Bonjour tout le monde. Bienvenue à ce dernier épisode du Montréal Java User Group de décembre. Bon, je vois les commentaires qui rentrent, ça veut dire qu'on doit être live pour vrai, ça c'est bien. Ok. Hop là. J'ai mon YouTube qui vient de se lancer. Voilà. Donc, je vais pas parler super longtemps. J'ai deux choses. Première chose, on a deux sponsors qui ont renouvelé. Donc, c'est pas vraiment des nouveaux sponsors, mais ils restent avec nous pour une prochaine année. Donc, nous avons Alicia en platine et la Banque nationale en diamant. Nous sommes bien contents de les avoir avec nous. Merci de leur confiance en cette époque de pandémie où les opérations sont différentes. Deuxième chapitre, je voulais parler un tout petit peu de ce qui se passe en Java. J'avais quelques petites nouvelles amusantes. Je vais essayer de vous trouver ça ici. Une des choses, pour ceux qui sont curieux, il y a Maven 4 qui est sorti en version alpha. Donc, il y a plusieurs améliorations là-dedans. Et je suis assez curieux de l'essayer. Je ne l'ai pas fait encore, mais ça me semble intéressant. Une autre chose qui est sortie, c'est Hibernate Reactive, donc une version réactive de Hibernate qui permet de faire de l'asynchrone avec Hibernate. Je pense qu'il y a beaucoup de gens fans d'asynchrone qui voulaient voir ça. Donc, c'est là. J'ai pas regardé, donc je ne sais pas à quel point c'est mature, mais ça vaut un petit coup d'œil. Il y a Nashorn qui avait été retiré de Java, l'émulateur de JavaScript en Java, qui en fait a été spiné en projet indépendant. Donc le projet est pas mort complètement, il est maintenu à l'extérieur du JDK, comme beaucoup de choses qui ont été sorties du JDK d'ailleurs. Et qu'est-ce qu'il y avait d'autre? C'est à peu près tout. Pour ceux qui suivent le GCP, and I'll do this part in English. GCP election went, the results were out in beginning of November, I think. In the beginning of November. So, I was there and lost, but I lost against people like Azul and Eclipse Foundation and London Java User Group, which is also at OpenJDK. So I wasn't really surprised because they're highly involved in the community and they're really strong. Who are the other ones? So there's three, for those who don't know. So GCP is the thing that manages Java. There's three categories. One is ratified one. So it's Oracle that selects some companies and then we vote for the one we prefer. There are then companies, and then there's the third category is like standalone human being. Let's call them like that. And so for the ratified seats, we had Alibaba, Bellsoft, which is doing an RM JVM, so something running on Raspberry Pi. There's Bank of New York Mellon in there. We have JetBrains, a company named Microduct that does JVM as well, and SAP playing in there. So so for the the real name is Associated Seats. So these are standalone folks. We're really lucky to have the elected guy speaking tonight because Ken was elected for that seat. So congratulations. And that's all for the news for today. I'm back. Let me put his slide on. Here are the slides. And so today we have Ken from Montreal. In a while, we haven't had someone from Montreal. It'll close the year. Next year, I need to talk about that. I'll let you, Ken, talk about JChampion Conf and Dawson. So you'll probably be able to give the correct date. So we have these two conferences coming beginning of January, but I'll let Ken detail about it. And end of January, we'll have Nicolas Frankel, who would speak from Switzerland. I don't remember the topic, but it doesn't matter. So, not sure it's decided actually. So, so that's all for the news on the Montreal Jug Reels. Wish you a happy Merry Christmas, Happy New Year, and everything like that. And I'll let you with Ken, who's Java champion, teacher at Dawson, and a friend of the Montreal Java user group. Thank God. Up to you, Ken.
Thank you very much. I believe I'm supposed to start every meeting with, can you hear me? So Henri says yes, so let's go ahead. What I want to talk about today is what I call Java best practices. Now, I've been teaching Java for many years, and so I've developed certain approaches, certain skills that I expect my students to follow. I couldn't help but play with the title for this, Java Programming Best Practices, or I guess everybody must be watching The Mandalorian, so we have to have a Yoda title, Code Good in Java, How To? Or how about a title that insults you? It runs and gives the correct result. You're fired. Or finally, just to emphasize that I'm old, Ramblings of a Java Teacher Who Was a Toddler at the Dawn of COBOL. I was born in 54. So a little bit more about myself. I've had an interesting career leading me to the classroom and to Java. I was a graphic artist. I was a freelance developer. And then I had the good fortune of being offered a position at Dawson College, where I am currently still a teacher since 1991. I've been chair and program coordinator of the computer science program, 96 to 2000, 2002 to 2020. I'm also a part-time instructor at Concordia University's continuing education. I had the amazing good fortune of being selected, being nominated, being voted as a Java champion. Actually, it was, I guess, a year ago, I decided to get even more involved with the community and ran for the Java Community Process Executive Committee. And it is quite, well, it's an eerie feeling as I'm sitting there as a teacher in a small school in Montreal. And Henri mentioned some of the companies that were reelected, but sitting at the same table is also IBM, Intel, and a number of other, and Oracle, obviously. So here are all these billion-dollar companies and little old me. I've also been organizing a conference, and I'll mention it again at the end of the presentation, called DOSCon. This is actually its 5th year. And if for some strange reason you want to learn more about me, you can visit my blog at omnijava.com, where I have a little piece of little story about how I got to where I am today. Well, let's get down to business. The students that I deal with are coming to us straight from high school. So they don't have any experience. Usually at open houses, students will say to me, well, what do I need to know? I want to be a computer programmer. What should I know before I come into the program? And I'll usually ask them things like, do you know where to turn on and off your computer? Or can you tell the difference between a mouse and a keyboard? It's funny, when I started teaching, these were questions that sometimes puzzled people. Luckily, not anymore. And quite frankly, I don't really care if they can turn on their computer or if they can tell the difference between a mouse and a keyboard. I really hope they can. They're probably, if they have that passion, the right stuff. The students that we teach at Dawson, when they finish their studies, and they, like all technology programs at a college in Quebec, the program is 3 years in length. And in the final semester with us, they go out on an internship. Now, we arrange the internship. The students don't have to find their own. The idea is that we are placing our students in companies where they already have a team of developers, and our students will become a member of that team. Only contributing code to the company's product is suitable for an internship. We're not looking for companies that are kind enough to have our students sit in the corner and file for them. They have to be involved. Many of our students are hired by the companies, and about a third of our students decide to go on to university. Please don't look at this as I'm looking for internship companies. We actually have, well, I wouldn't call it a problem, but an interesting situation in the current pandemic. We actually have more requests for interns than we have students. So, best practices. And let me be honest, some of these may seem elementary to you, but one of the things I've learned over the years, especially as I've gone to conferences and spoken to many developers, is that sometimes the senior people sometimes forget some of the basics that are important in software, right? As an engineer, you don't try and invent a new technology every time you start a project. Instead, you're looking to adapt existing patterns and technologies to meet your needs. Well, best practices in software work the same way. So let's take a look at some of the best practices that I expect my students to employ. We'll even take a look at some really bad code. So, best practice number 1. And I guess I should be counting down, but I'm not going to go 10, 9, 8. We'll start with what I consider probably the most important best practice. Read. Every problem that you're going to solve is going to require you to learn something new. I tell my students, when you graduate, you're not done. It's not like you're finished. You've now learned everything there is to know. Go off and have a great career. No, you're actually starting a career where you're going to have to learn something new every single day. And reading is how you're going to have to do that. When I started as a developer, and I started as a freelance, I spent close to 10 years going from contract to contract. When companies would ask me, well, we need a quote, I would always have as part of the quote at least $1,000 for research, specifically to buy every book I could find on the subject. Remember, this was pre-internet. So I would have to, there were a few bookstores in Montreal, and this is how I would acquire the skills. And that every time I had a new project, it didn't matter how similar it may have seemed to the previous project, there was still something to learn. There was still something to read. You need to read before, during, and after the project. Best practice number 2, is practice. In your reading, in your research, whether it's Stack Overflow or somebody's blog site, you're going to be inundated with code samples. Don't just copy and paste. I like to tell my students, set up a small little project with just that sample code. Poke at it, make changes to it, make sure you understand it. You've practiced with it before you place it into your project. Refactoring. I read a story that just baffled me. It was a story about a team. It was written by a young developer who was kind of overwhelmed by the fact that at a particular hackathon, a member of his team was a well-known luminary, somebody famous. If I mentioned their name, you'd know who they were. I'm not going to. That's mainly because I can't remember who it was, but I do remember when I read the article, he was famous and I knew him. This particular luminary, who took over the role of leading this team of small developers at the hackathon, made it very clear to them that they had to fulfill the requirements of the hackathon at any cost, right? It just had to work. Don't worry about code quality. Don't worry about organization. Just make sure when you said run, it worked. If they were finishing early, well, maybe they could go back and do a little refactoring. But it was the result was the only thing that was important. I really disagree with this, right? Code is not finished until it's refactored. I came across these two statements. Good code quality needs minimal refactoring, and poor code quality is resistant to refactoring, is difficult to refactor. I wrote this little script. As you can see, I have no future in the movies or television. Imagine a scenario where you go to your supervisor, your manager, and you say to them, that proof of concept, that idea we had, it's working. We're getting the right answer. The manager replies, great, let's push it to the client, and then I'll assign you your next task. You reply, wait a minute, right? Now we have to refactor the code so that we can maintain it and have someone other than me work with it. Likely because I'm going to leave this job because you're not a very good manager. The manager's reply is generally the budget, the company policy, or my incompetence doesn't support refactoring code that works. To which you go, not again. Comments. If there's one topic that comes up when I meet with people that I get a lot of blowback on, it's comments. I would say to my students, consider what would happen if you stood on a street corner. Let's put you on the corner of St. Catherine and Peel, St. Catherine and St. Denis, anywhere in the city. Get out a little box, stand on top of that box, and start reading your code out loud on a street corner. Would anyone understand what you were saying if they did not already have a background in software development? A lot of people like to say, well, code is self-documenting. But my experience is the only people who understand the self-documented code is the person who wrote it. Self-documenting is not enough. Why did you choose a particular algorithm? Those kinds of things are missing from comments. We once had an internship company, I won't mention its name, that forbid its employees from writing comments. Code had to be written in such a way that comments were not necessary. Students who went to this company, and they took a number of our students, and it was a good experience for them, they reported back how much time they wasted trying to figure out what the company's code did and why it did what it did. Comments are important. I will say now that one of the things I plan to do in the Java community process this year is to look at Java docs, all those beautiful HTML pages that we can generate. After teaching for so many years, I've come to recognize that they're not the best documentation for the Java language. We have to find a better way there. So, where do you comment? This is what I tell my students. You want a comment block before every class. Most IDEs make that easy to do. Explain the purpose of the class, why you coded as you did, what pattern are you using, and how to use it to the best advantage. This is what I find is missing from a lot of documentation. There's usually a line or two, this class does X, this class does Y. But do you really understand why or what the purpose was? What was going through the developer's mind? It might sound strange to say I want to see that in comments, but I do. Then, of course, before every method, the typical Java doc blocks, purpose of the method, parameters, returns, exceptions. But I also want to see something that tells me, how should this method be used? Now, the general advice we get is you comment public methods. You don't need to worry about private methods because they don't end up in the Java docs. Or even more strange is if a class has an interface, then you put all the comments in the interface class. And now, you don't need any comments in the implementation class. No, you need comments everywhere. Public, private, protected, package. You need to have comments. Now, you don't want to comment the obvious, and I see this from students' work frequently. You know, a comment where Bob equals age, and the comment says assign age to Bob. There are certain lines of code that are pretty self-documenting, right? Bob equals age tells me what's going on. However, one of the frequent things I see missing from a lot of documentation are things like limits on parameters. I have a method that's expecting an int, a double, heck, a string. So, gee, what should be the allowable range? I rarely ever see that in comments. What I believe is you can never write too many comments. You can only write too few. You find that comments pollute the source code and take up a lot of space. Well, most IDEs allow you to fold the comments up and have them out of the way while you're concentrating on solving that next coding problem. I recently had an experience, and it's embarrassing. It was the very first time I was contributing to an open source project. And this was an EE, basically a basic example of how to perform a particular task in a web-based program. And when I submitted it, the people responsible took a look at my code and immediately sent me feedback telling me, first of all, why did I have comments in an HTML file? Then I was criticized for having comments in my Maven POM file. Now, as I say here, I did give in. This wasn't my project. This was somebody else's sandbox that I was playing in. And that did make them the final arbiter. And I did remove most of the comments, or not most, all of the comments from HTML, pom.xml. I even was criticized for writing too many comments in the source code. So I trimmed that down a bit. I have to tell you, to this day, I regret giving in. In hindsight, I should have actually refused to submit to the project if they told me I had too many comments. This is one I fight with people all the time. I drive people crazy on Twitter over this. What's main for? I started back, my first language was AppleSoft Basic. Then I learned assembly language, and then GW Basic, and then finally real programming languages. I used Pascal, C, C++, and of course now Java, and I'm learning Python on the side as well. But what I recognized, whether it was the main function or method in Pascal, main in C, main in C++, and main in Java, is it has one simple role, and that is start the program, instantiate that first object, and hand over control. I would always describe the main method as a program's chief executive officer. CEOs delegate work to their staff, which I call the non-static methods. A main method should not be rolling up its sleeves and working on the shop floor. More than 2 or 3 lines of code in main, as I express to my students, means you're doing it wrong. Let me show you an example of this. Every semester, every fall semester, I give my students what I call a warm-up project. Now, I teach the project courses in the program at Dawson College. We do a desktop application in the fall, and we do a web application in the winter. So I am meeting students for the first time because I'm only teaching in the third year. And so I need to get a sense of what their skills are. I guess maybe I'm checking to see how well the other teachers did. I'm not sure, but I need to get a sense of it. So I asked them to write a program for a simple game, a dice game called Pass Line. Pass Line is the type of dice game you frequently see in the movies, where the player keeps rolling the dice and eventually either wins or loses. This is Pass Line. So I hand out to my students the rules, how the game is set up, and all I tell them is, you have to write code to impress me. Show me your best coding. Let me show you, sadly, one of the most common types of submissions that I get. Here we go. Here is a student's program. Now, I want to tell you that almost every student, and this year I had 54, so I think 52 out of 54 were able to submit a program that worked. It played the game, did everything I said they had to do, and of the 52 students, I gave a 0 to 48 of them. Why? Because they treated programming as a kind of stream of consciousness exercise. First of all, take a look here. Everything is in main. There are no methods. There's no separation of concerns, no single responsibility. It's just one long piece of code. And, they knew I like comments, so I get kind of meaningless comments like this. But it just goes on and on and on. I would hate to be a working developer trying to support this code out in the field. The other thing that would get me about my students, that would get them a 0, is they would structure their program, but they'd make everything static. Why waste time with instantiating objects? If everything's static, it's one big happy family. Well, if you want to write code where everything is static, there is a language for that. It's called C. It's not called Java. Let's return to our slides. So this is what I show to my students as the perfect main. Inside of my static void main, I instantiate the first object. It could be the class I'm in. It could be an entirely different class. And then I transfer control. Perform is just a word that I've come up with. Any term is fine here. If we were doing Java FX, well, of course, there'd only be one line here. It would be the launch command. But when I see in main initiating variables, calling upon a range of static methods, because of course you need to be able to access them from main, I go, wait a minute, this particular individual, this student hasn't quite grasped the concept of object-oriented programming. Naming conventions. How do we name things? Here, I'm going to blame somebody. I'm going to blame mathematicians. You see there in the notes when you're taught, Pythagoras' theorem, how to calculate the length of a hypotenuse on a right-angled triangle. It's always shown as a squared plus b squared equals c squared. Well, I've always had trouble with a and b and c. Couldn't they have just written side 1 squared equals plus side 2 squared equals the hypotenuse squared? Sometimes I think we could have all done better in math if instead of all those strange English and Greek letters, somebody actually wrote out what that was supposed to mean. Proper names would have been a lot more useful. So we have our Java naming conventions. The camel case. We're all familiar with it. Take it a bit further, of course. Variables should be nouns. Methods should be verbs. Names of classes, it's a kind of toss-up, verb or noun. I tend to lean more towards noun. When we use uppercase, we all work on the assumption that if we see an identifier in our code that begins with an uppercase letter, it's a class. And if there's a period and a method name after it, then we make the assumption that that method is static. But if the person who wrote the code just didn't respect the convention, we are going to misinterpret what they're doing. Of course, we have all uppercase letters for constants. And again, there's sometimes some disagreement here, but to me, a constant is a final static, not just static and not just final. It has to be final static. And again, be expressive. Use camel case or use underscores if you're capitalizing everything for a constant. Some years ago, and this is an outgrowth of work that Microsoft did, they came up with something called Hungarian notation. And I will tell you that for a few years when I was teaching C++, I encouraged my students to use it. I thought it, helped document what they were doing. What I've discovered over the years are there are reasons for and against its use. For me, though, what made me come to the conclusion that Hungarian notation was not the best technique for naming was refactoring. If in the course of development, you suddenly decided to change a variable that was an int to a double, well, now you had to make sure that you refactored that identifier throughout your code. Here I saw the potential for hidden problems. I also was puzzled by, there seemed to be a lack of standards. Is an integer an I? Is it an N? Heck, at one point it was a D. Well, I'm not going to say don't use Hungarian notation. I'm just going to suggest that you are vigilant, that you're very careful and consistent if this is the convention you plan to use. Best practice number 7, testing. Now, I shouldn't have to tell you this. If you aren't using a testing framework, then maybe you should consider another job, another career. I tell my students that code isn't ready to be tested by a QA department until you've tested it with unit tests. If a public method changes the state of anything, it needs to be tested. But it gets easier. All public methods change the state of something. You need to validate. You need to verify. What I see students who come to me, and I'm the one who introduces JUnit in our curriculum, they're all writing programs where they're using main to try and test what's happening. Well, as it says, see, best practices 5, that's not what main is for. And so when the boss asks you if the code is working, the reply should always be, once the code passes the tests, I'll be able to tell you. Best practice number 8, software patterns. Take patterns seriously. You know, they come to us from the field of architecture, right? If a builder is going to put up a bridge, or an engineer, that engineer is not going to invent a new technology for holding a bridge up in the air. Instead, they're going to look at the available technologies, the available patterns, and then design a bridge that employs that particular pattern, whether it's our brand new Champlain Bridge or our very old Jacques Cartier Bridge. Each one of them are built to a recognized pattern. Much of what we do in software can be associated with patterns. You should be able to recognize a pattern in code that you're writing or that you're reviewing. I have here as the illustration, though, two widely used patterns that should never be used. Of course, you recognize the first pattern. It's the kitchen sink pattern. We could say that code sample that I showed you, my students' pass line game, all in main, is an example of the kitchen sink. Just keep throwing code. Something doesn't work, you can solve it with more code and more code. Or the stream of consciousness. I used that term when I looked at that student code, right? Start a method and just keep adding to it as you think of things. These are not patterns you want to follow. Best practice number 9. The operating system is irrelevant. If you're coding Java, let's use that as an example, to take advantage of unique features in Linux, Mac OS, or Windows, then in my opinion, you're doing it wrong. I really believe strongly in the concept of write once, run anywhere. We seem to have forgotten that. The rise of containers seems to have been a response to that suddenly developers couldn't trust that their code would behave the same in different platforms. So the decision was made, the platform is going to be Linux, and we're going to have a container for every system. I don't think you need to do that, especially if you're programming in Java. You should be writing code for users. You should be writing code for the Java virtual machine. If you're developing software, consider running your unit tests, your functional tests, your integration tests on more than one OS. So another company, who I shall leave nameless, I was using a library of theirs, and I was having a particular problem in the Windows environment. Now, I develop in Windows because this is the system that the college deploys on all of the college computers. And again, the beauty of Java is if it's written in Java, it'll run anywhere. So for this particular library, I had a problem where, and it was a testing framework for enterprise, that regardless of how simple the test was, it took about 30 to 40 seconds for the test to complete. And of course, if testing is going to be that incredibly slow, well, people aren't going to want to use it. So I reached out. Well, I actually complained on Twitter, but that's the same thing. And in no time flat, I heard from one of the developers of this particular product. What's the problem? I said, well, I'm having this delay. Their response was, gee, we've run your sample code, works perfectly here. And I went, oh, well, must be me, right? Here's another principle I tell my students: if it doesn't work, it's always your fault. So working from that assumption, it was my fault. Okay, let's see what I'm doing wrong. Well, I couldn't find what I was doing wrong, and it was frustrating. And so in the course of trying to solve this problem, I decided to change the application server I was using. I switched from Glassfish to Payera. Suddenly, the problem was gone, which of course didn't make a lot of sense because Payera is effectively Glassfish. So again, why did Payera take care of it? So I spoke to some of the developers at Payera, and they told me how they had discovered a particular issue with file management under Windows that required them to change the code. Now, not change the code just for Windows, but change the basic code that did file handling so that it would work across all platforms and resolve this Windows problem. Great. I got in touch with the original developers of the framework, and I said, hey, Pierre has solved it. How could you not see it? And that's when they admitted to me that they did not have a Windows machine in the office. No one had a Windows machine. They'd never even seen their framework work on Windows. They just assumed that if it worked on all their Linux boxes, then it must obviously work the same everywhere. That's why I believe that you need to test your code across all platforms. And if a particular platform is underperforming, then it's not about creating a version for that platform. It's about finding the error, the problem in the basic code that affects a particular platform and not the others. Best practice number 10, IDEs and build systems. I've always believed in IDEs. I know the adage, you're not a real programmer unless you use a text editor and a command line compiler, but I've got better things to do with my life than fight with those, right? I like IDEs. I don't really care what IDE even my students use. An IDE to me is a very personal choice. Whether you use Eclipse, whether you use IntelliJ, or my favorite, which is NetBeans, it's what you perceive as making you a better developer. And I think over the course of your career, you should always be exploring all the IDEs as they evolve and change in the way they work. But when I use an IDE, what I never do is use the IDE's built-in or custom internal build system, right? And we know they all have them, or at least 2 out of the 3 do. We know that Eclipse has their own build system. We know that IntelliJ has their own build system. NetBeans always used Ant initially. But what I tell my students is use an external build system. Don't use the one that's part of your IDE. Use Maven. Use Gradle. Heck, in a pinch, I guess you could still use Ant. Keep in mind that the long-term maintenance of the software you write is going to involve many people and will likely continue long after you've left the company. If you've written software that requires a specific IDE to be able to build that program, you have a problem down the road. Use a build tool. Ooh, we have some bonus best practices. How about consistency? This is a question I ask managers, and usually every year at Dawson, we meet with the managers at the companies that take our stagiaires. And one of the questions I always ask them is, does your organization have a manual of best practices, right? When you're onboarding someone, can you, describe to them, what standards the company follows? And the most common thing that I hear is, no. We expect all our programmers to know what the best standards are. And of course, the result is the get it to work at any cost. What do you do if you work for an organization that doesn't have such a manual? Well, I hope you write your own and share it with the other people. Best practice. Here's our double bonus. Static. Here's another thing that puts me in conflict with people at conferences when we discuss this. Now, when I moved from C to C++, my understanding of static variables and methods was that they were created to avoid the overhead of object-oriented programming. That there were situations where the management of all the necessary pointers, the allocation of memory could in some situations represent a bottleneck, a problem with performance. And so you could kind of move outside of the object-oriented world and call upon something that's static. The problem here is that the performance issues in C++ are not the same as for Java. So this is what I tell my students, and I know many of you will disagree with me, but what I tell them is there's only 4 valid reasons for making something static. Number 1, methods of a general nature. And we always use the math library here. So if I say math.pow, I'm calling upon the power method. Calling that method tells me nothing about why I'm calling it. Tells me nothing about the problem I'm solving. It's capable of performing a task that can be coded in a single method, and because of its general nature, you can argue there's no need to instantiate this class, just use the method. The other reason for static anything are for variables that are used as messengers between different instances of the same class. And of course, the singleton pattern is where this is frequently used. The arrival of functional programming in Java, where we can define functional interfaces. These require static methods. And finally, shared constants. I don't know about you, but when I first learned Java, I read that the best way to handle shared constants was to put them in an interface class. I've since stopped doing it quite that way because I have no intention of using the implements to provide constants. Instead, what I create now are classes that have a private constructor and static final members. These I can now import in such a way that all I need to use is the identifier. I don't even have to use that static class. And as a triple bonus, and I added this just yesterday because I saw this just this week. And of course, what you don't want to be is too clever. That programming is not about, trying to outdo the person sitting at the next terminal, right? That somehow your code you found a way to combine 6 lines of code into one illegible, unreadable line of code. When I looked at this, I went, well, you know what the next word is. Heck, I even called up a spreadsheet and entered it in just to make sure it was exactly what I thought it was. You should all recognize that that's ++I. I'm not quite sure what this student was thinking about. I don't know if they were trying to impress me with their cleverness. Clever code can be a problem. You want your code to be inventive. You want it to be imaginative. And you also want people to understand why you did something. When I look at this, I don't have a clue why someone would write this instead of ++I. So let me almost end. I have one more slide with a little more advice. Write your code as if it'll be running till the end of time. That might sound strange, but if you take that attitude that you're writing something that could last forever, and we certainly know there's a lot of code out there that's still lasting. The government of Canada every year, sends somebody to meet our students to encourage them to come and work for primarily Revenue Canada. And one of the things they tell our students is, if you come and work for Revenue Canada and you take COBOL training, we'll pay you an extra $20,000 a year. That's a lot of extra money. A lot of our students who go to Revenue Canada usually don't want to learn COBOL. But There's an example of code that is running till the end of time. Also keep in mind that the code you write is likely code that you may never work on again. I tell my students, you will work at a company, your first job, maybe you'll be doing maintenance on other programmers' work. Eventually, through promotion, you'll start generating your own unique code for the company's product. And then you're going to find a better job. And then the cycle begins. Somebody else enters the company. Think about the people who come after you. Or as I say at the end there, assume that you'll be hired at your next job by your former workmate who had to look after your code at a previous job. I want to finish with some plugs, and actually I forgot to add one plug, and Henri mentioned it. So first, there's DawsonCon. Some of you may be familiar with it. This is a conference I've started. This is in its 5th year. Of course, it's online like everything else, but we have an amazing lineup with 24 different speakers. Henri is one of them. We have Venkat coming. This is Venkat's 3rd year speaking at DawsonCon. And we have speakers, well, not quite from around the world, but we have speakers from South America. We have speakers from Africa, Europe, the US, and obviously from Canada. Now, although I don't have a link here, Henri can send that to you. There's another conference that I'm involved in organizing with the Java Champions, the Java Champions Conference. This conference runs around DawsonCon. So DawsonCon is on January 15th, and there are 24 sessions in one day. The Java Champions Conference runs on the Wednesday and Thursday before DawsonCon, and the Monday and Tuesday afterwards, with 6 sessions each day. For both conferences, nobody really expects anyone to sit at their computer for 6 or 7 hours watching session after session. But that's why we have so many sessions, that there will be one or more that you will want to see. So please check us out, and please help my ego and follow me on Twitter. With that, I want to thank you all. And I guess if you have any questions or comments, Henri can moderate it, and I will stop sharing my screen.
I'm back.
Hello, hello.
I learned that I can put the comments on the screen whenever I want, but I'm not mastering that new feature yet.
As you can imagine, it's difficult as I'm speaking, and I notice out of the corner of my eye or on my second screen that there are comments coming in, but, you know, to me, it's a show. I'm performing. I actually try and avoid comments because it throws my rhythm off.
No, you're right. You're right. I tend to read them too much, actually, when I do these things. So, any questions? Please just post them, and we'll answer.
Ooh, I see 78. Whoa.
There's a question about, can you talk about the levels of the students in your 30 years of teaching? What's the difference, and is any difference due to internet, mobile phones, or Stack Overflow? That's the question.
Not really. The students are, you know, these are, as I mentioned, students who've just come out of high school, so they don't have the kind of experience. So Stack Overflow is something they're starting to see. What I do want to stress about, you know, our program, and we have to compare it, at least here in Quebec, to university-trained developers, people who take computer science. We focus on training our students to be working developers on the first day of the job. So we don't have a lot of math classes. We don't have classes on understanding the theory and principles behind a stack or a linked list. We focus on what are the skills you need to get the job done, and make sure you understand what those skills are. So Stack Overflow, they look at it, they scan the internet, but typically they're not yet ready to understand what they see. Now, what I do in my courses is I generate a great deal of sample code. This semester, the students had 52 different samples demonstrating the range of concepts from database to Java FX to Java collections. And when we do the web program, they'll actually have 70 samples, each one of them looking at a particular aspect of enterprise programming that they'll need. Gaining experience from what I will call the curated samples makes them now better able to make sense of what they see in blog posts or Stack Overflow.
Thank you. What else? It seems like what we learn at school are so different than what we do in companies. So how to really close the gap? Do you think today university are teaching too much theory? Yes. Okay, I'll let you answer.
So I have a, I mentioned at the beginning of my presentation that I have an unusual path. So I became a tenured teacher at Dawson College without a university degree in anything. Right? I brought home an Apple II computer in 1980. While I was a photographer, I became obsessed with it. And within 3 years, I was doing contract work. I was teaching non-credit part-time. And then I became a teacher. And when the college made me a tenured professor, which really just means in the CEGEP, they can't fire me, I decided, gee, I should go and get that degree. It probably is something I should have had. So I went to Concordia, and it was one of the most frustrating experiences in my life. Now we're talking about 94 to 98. Every one of my professors was a mathematician. Now, again, that's more than 20 years ago. None of them were working programmers. As a matter of fact, what absolutely baffled me was that the computer science department at that point in time at Concordia actually employed professional developers to write code for the professors, because the professors didn't write code. It was frustrating. No one would talk about clean coding style. It was just about get it to work, right? The TAs are stressed. They have to mark your stuff. And so this is what we see when we put our students in companies alongside university stagiaires. Yes, the university stagiaire has had training in the concepts, the mathematics behind it, but they stumble around IDEs or unit testing, whereas my students come in and they're ready to be productive right away, given, obviously, sufficient direction. I really think universities have to take a look at what they're doing. That some of the emphasis on concept, on theory, is taking time away from training someone to be a productive programmer.
I take a lot of interns these days, and you're right. I'm still surprised how much they don't know about development. So they don't see at school anything about unit testing or TDD, even more, of course, or even using Maven or whatever, like any normal things that they will need to learn in the company at day one, and that should help them actually do their work at school, because it's super helpful to be able to unit test your code at school and to be able to use Maven and test and use libraries and things like that. And you're right, they do not learn it. They learn it the hard way when they go in internship in general, which helps a lot. Thanks God they have internships, but you're right. It's strange that they don't have an actual structured course of that's how we do it in a real company for real applications.
Well, what I see is a lot of universities have co-op programs.
Yeah, that helps.
And the purpose behind the co-op is it kind of absolves the university from the responsibility of teaching their students how to code. They expect that from the co-op company. And I don't think that's, if I own the company, I don't want to bring in a university graduate and have to wait 6 months before they're productive.
Yeah, absolutely. And unit tests are hard. Like getting out to do your testing is not that easy. Or add stuff about like dependency injections. My poor students were fighting how to get class to interact with each other, and like after one day, I got them like, what's wrong? What's so complicated in there? We don't know how to. That's like straightforward dependency injection. You just do it like this, like this, like this. That's done. Problem solved.
Well, I look at the future of development, and especially next term when I do web and we do Java server faces, and CDI is a big part of what we do. There's still a part of me that wonders why we still even bother to say new anymore. Between modern frameworks, most frameworks can figure out when it's time to instantiate an object. I think, the best way to end null pointer exceptions is to get rid of new.
Let me see. There's a question about comments, because there was a big debate on comments. So what is it saying? They are useful, but I believe writing a lot of them requires extra maintenance, and eventually devs stops updating them, leading to lying comments. Is it fine?
To me, this is a question of professionalism. So when you go and see your physician, your general practitioner, one of the things that I notice, and I'm fortunate my general practitioner is a close personal friend, he spends more time writing than talking to me, because he's making comments. He's keeping notes on what's happening, so that if I come back in 3 months and 6 months or a year, he can look at my history. He can understand where I'm coming from, what problems I had. And it seems to me that as a programmer, we need to do something similar, right? And that's the purpose of comments. It's not just, okay, today this method does this, this is the range of values. And so, yes, the idea that, well, people will evolve the code, will maintain it, will improve it. They probably won't be maintaining the comments. To me, I'm going to say something insulting. That's a lack of professionalism, right? As a professional developer, you have a responsibility, in my opinion, and remember, that's me, so just say nasty things about me, that you should be not only maintaining your code, but you need to be maintaining your comments.
I fully agree. Comments should be maintained. And there was a discussion about, if we could use good naming and annotation to get rid of all comments. My comments to that, let's call it my comments to that in general, is if you look at the JDK code, you will see a lot of line comments. And these are made by Brian Gates and Josh Bloss, and extremely wise, like wiser than I am people. So if they do think putting line comments is useful to others, they're probably right. I don't know. That's me. And I'm really happy to have their comments to explain the algorithm and even the source of the algorithm, that is like page 244 from Donald Knuth something, or it sounds useful. But that's
cool. I'm reading a comment here from Pierre Caron. Hi, Pierre. We've met. I should add a good practice: don't code with your grandma's Java. Absolutely. I don't know if any of you have seen, it's still in preview, the new Switch. Oh my, it's glorious. Still not as good as the Switch in Visual Basic 6, which I still contend was the best Switch ever built, which, by the way, Microsoft destroyed when they went to .NET. But the new Switch, the fact that it's a statement, it's an expression, we should be adopting these new, concepts, lambdas, streaming, though there's still a lot of argument about streaming one way or the other in terms of performance. But to me, it really can simplify the code if done right and complicate the code if it's done wrong. But definitely take advantage of the features. You know, Java 17, the next long-term support release is coming out. It saddens me that next term when I teach Java Enterprise, we've got to leave. We were using Java 14 because we started in September. We've got to go back to Java 11 because Enterprise sits on top of long-term support versions. And not even right away. I suspect when Java 17 comes out, the next long-term support, it may be a year or two before the application servers adopt 17 as their runtime.
I was looking, I think we're through all the questions. No further questions. No.
So don't forget to sign up for DOSCon. Don't forget to sign up for the J Champions Conference. Don't forget to follow me on Twitter so I can have a really swollen head thinking a lot of people actually like me. And, you know, get out there and code. And if I can be of assistance to any of you, I should point out that this is actually my last year in the classroom. I'll be retiring from Dawson in June, but hopefully not from the industry. Heck, I actually turned down a job from Microsoft 2 weeks ago, only because they needed me now, and I didn't want to be available until June. So who knows where I will be, whether I'll be writing a book or, you know, contributing more to open source. I'm just not going to be sitting in a rocking chair on the porch. I figure if the current president of the United States is going to be 78 years old or 79 when he takes office, that means I've got a good 15, 20 years ahead of me of being productive.
Good. I hope. Thank you very much. That's it.
It's been my pleasure. Thank you all for coming.
Yes, it seems it was appreciated. And again, to everybody, Merry Christmas, Happy New Year, passez de belles fêtes, and we'll see you for all these events in January. Bye-bye. And